Are we live? We are.
Good afternoon, everyone. Thank you for coming to our talk. My name is Eimear Loughnane. I'm Senior Director of AI Solutions at Amach. My colleague John, you want to introduce yourself? Tell us a little bit about Amach.
Yeah, John Power and Chief Product Officer in Amach, and we specialize in cloud data and a lot of AI acceleration activities. But before we kick off, I'd like to maybe just comment on what a lot of Faraz has said earlier in the last session, which is all really, really relevant. Okay. I've talked to maybe 100 airlines over the last 12 months, and the recurring theme of data keeps on popping up. All right. So I'm probably going to use AI once, and this is it, but without actually having clean sets of data, any sorts of initiatives in that particular area aren't going to go very, very far. So put as much time and effort as you can into making sure that your sources are correct, accurate, and clean. Your data pipelines are clean and accurate. Then you can start leveraging that particular data. So this whole concept and sexiness of AI is only as good as the data that actually it can provide. Okay, so let's kick off, Beamer.
Thanks, John. We're going to talk a little bit about operations today. We know that efficiency in operations really is top of mind for every airline out there today. We know that margins are tight, we know that costs are rising, and disruptions happen all the time. We also see that data tends to be siloed, as we all know, across many different systems, and this can really slow down decision making. And this can make things really costly and really difficult. We see this at Amach a lot when we work with airlines across all the different life cycle stages. But we've got a few questions here for John. We're going to delve into this topic a little bit more. We'll start with delays. We know delays can be really, really costly. And one of the ways delays tends to happen is with passenger mismatches. We've all been there waiting to get on board and really getting a bit frustrated, right? So if we can identify these patterns and the root causes of what causes these passenger mismatches, we can really help to predict when they're going to happen and get people in place to mitigate against them. Can you talk to me a little bit about how Amach has implemented this with some of our customers?
Yeah, and I think again, you need to concentrate on where the business value is going to be driven from. So again, all of this particular technology, it's just a tool. Okay. So our approach here is very much when you're talking about initiatives, what's the KPI? What is the business value you want to drive from this? So in this particular scenario, what we actually had was we had a model that detected patterns specifically around late inbound evening flights from regional airlines coming into us. Very, very tight connection windows, and they were beginning to miss their connecting flight directly. So what we decided to do was, now that we've got a pattern, let's see if we can improve on that. And this is where the value really is driven from, is that we're looking to actually have gate boarding staff start to go through these lists to see who's checked in versus who's actually boarded on the plane. From that, they'll start making decisions based around what they actually should do. Secondly, from that scenario, what we do is we notify the OCC to turn around and say, there's a large number of people from this specific flight, regional inbound late evening flight, that are going to miss the connection flight. The OCC then has a decision-making process. It either decides to hold the plane from disembarking or automatically start providing options to the passengers about what they want to do in relation to rebooking. So what we're trying to identify there is what is the improvement we can take from the technology? Technology's done its job. How do we improve on it? The second one was an identification where flights to specific popular tourist areas kept on getting errors associated to exit row seating. Minors were being put into these exit row seats by accident. So what we were doing again was the gate staff would double check before the flight was started to embark to see if there was any minors in those exit row seating. If there was, let's remove them straight away. So all of a sudden, the advantages from this is that the disruption is way down. You're proactively getting ahead of any of these disruptions in time to make sure the flight actually takes off. And again, you have this process improvement in place where you find something, you try it, you fail faster.
Brilliant. So that really has real impact for customers and for the airlines. Another cause of delays that we see, and a big topic in the industry, is around maintenance. It's often quite slow and quite inconsistent, and a lot of the software used today is still quite manual, and communication can be slow because it's done usually through emails. If we know that AI has the potential to communicate to engineers in real time, if we can do it and get faster response times, that can really cause less cascading disruptions, I think. And really, there's the potential to go even further and forecast things like wear and tear and potential failures. Have you seen this working in practice?
I have, and I'll have to admit, I actually fly scale remote control planes, Second World War remote control planes. Now, this case really resonates with me because vibration destroys engines and frames of remote control planes and they crash. Okay. But in this particular scenario, what we had was we noticed with a particular aircraft that there was a recurring issue associated to a fueling pump. Okay. And we decided what we do is we take information directly from aircraft sensors as well as MRO. We plug that into a model and it started to detect vibration issues associated with this aircraft that were having a knock-on effect on the refueling pump. So what we decided to do was to put a rule in place to say, when you hit an 80% probability of failure within 50 cycles, plan maintenance for that plane. In other words, take it out, replace the actual refueling pump, and then get it back out. The immediate impact there is you don't have any unscheduled downtime. So in other words, you got an unscheduled downtime, you're going to have 2 hours worth of a waste until the actual plane gets replaced with a new pump. Also, the flight could actually get delayed and you're into whole EU26 world worth of pain.
That has a lot of impact too. Brilliant. Crew steering, another area that's full of complexity. It generally kind of depends on multiple sources of data, and the data doesn't tend to be updated very often. We've seen predictive models that can forecast lots of different things like shortages and trigger early alerts. And what this does is it can allow controllers to move away from this constant admin and get really into faster decision making and scenario planning. And if you've got faster crew allocation, you get less last minute cancellation.
Yeah.
Can you talk a little bit about this and some initiatives that you've seen?
So this one again is incredibly simple but powerful. Okay, so most airlines have designated sick lines where people would ring in sick to a specific sick line itself. And in this scenario, what we did was we put a basic chatbot on the sick line that was monitoring what was happening on the sick line, and it would prioritize senior staff that would ring in sick. In this scenario, you had a captain that would have rung in sick. Okay, the chatbot would be able to get the flight and the name of the actual captain itself. Now, what would normally happen is OCC dashboards are updated every hour, right? So it would be an hour by the time the OCC would get a notification that this particular captain has called in sick and can't make the flight. With the chatbot has two scenarios here. Number one, it can automatically communicate with the reserve captain straight away and tell him to come in. He'll be in 20 minutes. Flight takes off on time. Alternatively, we can notify the OCC directly in near real time. And Faris was talking about this earlier. In near real time to turn around and say, captain has rang in, here's the flight number, pull in the reserve captain straight away. A very, very simple installation. Chatbots are on every single line. And again, it's about improvement, seeing what works. This one was really, really effective because again, the flight took off on time with the reserve captain brought in. And you didn't have to worry about cancellations and all of the E261 compensation claims that would actually occur off the back of that dissatisfaction to CSAT.
Brilliant. So I'm seeing a bit of a theme here about getting data to humans faster. So it's not just about using AI to replace people, it's about using it to get data to people faster to let them make those decisions. And even flight planning is changing. We've seen traditionally that conservative estimates have been used when looking at payload. And the reason they're conservative is to account for unforeseen variables like weather and weight. And capacity then tends to be underused because they're conservative. With AI, we know it's possible to have more precision in these estimates, and we can kind of cluster deviations into scenarios around those variables. What that can do is it can unlock unused payloads, and that can lead to incremental revenue gains. Have you seen anything in this space?
Yeah, and again, if we look at let's not try and rebuild a wheel here again. And I'll go back again, just my own personal phrase, but Faris used earlier. We need to fail faster. And a lot of the airlines I'm seeing at the moment are looking at initiatives within under 6 months. If they do not provide value, they get rid of them. So it's a derivative, really, of what Air Canada was just talking about earlier. It's give me an initiative that can have an effect within 6 months. Now, in this particular scenario here, as you rightly pointed out, every single aircraft has got a maximum lift-off weight, okay? And planners traditionally, historically, would have created a buffer in a conservative amount of weight they would have put onto that particular plane. That would have limited the number of seats sold because the actual flight has already been at full capacity. What we've done there is we've taken data from electronic flight banks, EFBs, Jeppesen. We've just a partnership set up with Jeppesen if anybody's interested in relation to that, as well as passenger profiles. We take that data in and we could accurately forecast 4 weeks out a lot better than the historical planners who can put in those conservative baggage weights in relation to that. That results in more ticket sales and more revenue in relation to the airline itself.
Makes sense. Thank you. So thanks for all the insights. What we've seen today, I think, shows that real meaningful impacts are possible using AI. It really gives us the ability to speed up decision making and, in the end of the day, to save some money. And we can all move away from these constant disruptions with predictive and proactive maintenance. At Amach, we're delivering over 50 use cases at the moment across 8 stages of the airline life cycle. And each of those is focused on, number one, stability, cost reduction, predictive insights, and real-time decision making. These aren't just experiments in a lab, they're live initiatives, and they really are showing results already. We're seeing about 30% fewer last-minute staffing issues, and that leads to 15% faster onboarding with ground operations. In crew management, we're avoiding cancellations, and that can save 8,000 per flight. We are getting a payload unlock of somewhere between 5 and 7%, and that can drive somewhere between 3 and 5% uplift in revenue. And in maintenance, if we can predict maintenance, we can unlock an extra 12% time and fleet availability, and that reduces unscheduled maintenance by about 20%. So the results are real, and I think that this hype in AI is not hype. If you're careful, if you know when and where to use AI and where not to use it, you can deliver real meaningful results.
Yeah, it's take it slow. And again, this message I've heard quite solidly for the last 2 days is start small, bring the business along with you, display early quick wins, and then that's when you'll gain confidence to be able to move on to it. So within Amach, we have a journey for AI acceleration. It starts out with basic, moves into intermediate, and then into advanced. Okay. This journey can take up to 2 years. And what I found again is once talking to airlines, once we get into any sort of hackathons around particular candidates or use cases, they actually realize their data isn't ready. So always look at the data first before you embark on this, because then you'll be able to avoid the Air Canada situations of wasting 10 million on a particular project before you realize that was a no-no. Eimear, thanks very much.
Thank you. We're in booth 267, just across there. Come and talk to us if you're interested. Thank you.